Which of the below are true? Ah. So it's kind of implying that there has to be at least two true because it's plural are. I don't know if that's actually a legitimate way to think about it or not. Okay. Focus. So we got some integrals here. So number one, we have integral f prime of x dx equals f of x plus c. Yeah, that seems reasonable. I'm good at that because, yes, I will say true. Integral f of x times g of x. No. So this kind of sort of looks like the product rule, but so if you had f of x, big G of x, and you took the derivative of this, then you would get something like f g of x plus f g of x, where you'd have the, this is the same as u v prime equals u v prime plus u prime v. Well, I guess it's swapped, but the same idea. So that's trying to confuse the product rule somewhere along the line, which is just completely wrong. The inverse of the product rule is integration by parts, and this is nothing like that. So, no, this one is not correct. No, all sorts of wrong. Okay. 3. Integral of x f of x dx equal, no. So what they tried to do here was they tried to pull out the x, which you can't do. There's no other way other than, I guess, just memorizing what you can and can't do with integrals. The idea of integrals, I like to think of it back as Riemann sums, which you can think of as basically just area under the curve. And to me, that kind of helps. I understand it's a little bit abstract for people that are just getting into calculus, but you can pull out constants, but you can't pull out the variable like that. Nope, because when you take for starters, you can think that when you take the integral of x dx, you get x squared over 2, and there's no squares here. There's no over 2, and even then you'd have to take the x and put it in. Incorporate it with the f of x. So, nope, not true. That does not work in life. Okay, so this says you have an integral of 2f of x, integral of 3g of x, and it gives you, now this is true. Here you have them multiplied together, and it tries to just sort of product rule them, which you can't do. But if you have integrals and they're separated, so this would be 2 integral f of x dx, which would then go to 2 f of x, and then you'd have plus c. I'll call it c1, and then you'd have 3 g of x dx would go to negative 3 big G of x plus c2, and then you could be like, well, c1 plus c2 equals big C. And that's kind of what they did. So they combined the constants and then just separate the integrals. So you can do this because these are constants. If these were x's or 3x's or 3x squareds, would not be able to do that. But since they're just constants, you can. And the way I like to think of that you can do that is area under the curve. If you have a constant times an area, then it's just twice the area. It does not work for variables like x and t, etc. Unless, of course, I guess those variables are constant, but we're going to keep this reasonably simple. So 1 is true and 4 is true. Now this is kind of a tricky question because this is the sort of thing you'd kind of see on a AP exam, because it actually tests quite a bit of material, but it does it in a relatively innocent looking manner, and it can be relatively quick. So this is the sort of thing you might see. It's good to understand this kind of problem and work through these sort of things because it really tests a thorough understanding of what you can and can't do with integrals. So 1 and 4, 2 and 3, completely false. So that is how you approach this problem. Just work from top to bottom, find out which ones follow the rules, which ones don't. And part of this even if you don't know the exact reason why one of these is incorrect, it's good at fine-tuning your spider senses. You're kind of like, oh, that doesn't feel right. And I know that's not a good long-term strategy in life. But in the end, for the AP test, you only need like 60% to get a 5. So you don't have to be perfect, and you can kind of, you can make some mistakes and still do pretty well. And so trusting your instincts and honing your instincts, though not 100% perfect, can do pretty well. So that's my advice for this kind of problem. I will see you on the next one.